In our last video, we had learned about the quadratic formula and that it can be applied to any quadratic problem. However, it doesn't mean it's the most efficient for every quadratic problem, so we're going to practice a little bit. So for letter A, the square root method is always the fastest, but obviously it's not set up for the square root method to be used. So my next choice of speed is, because this is a 1, I'm going to see if I can factor it, if I can find something that makes 3 and negative 4, and I can, negative 1 and negative 3. So technically this factors into x minus 3 and x minus 1, to which you can solve and get 3 and 1. So you can see that that definitely is a lot less work than writing out this formula, putting numbers into it, and then moving forward with that. So again, I'm always looking for the most efficient way to solve the problem that's going to consist of the least amount of steps. I'm going to jump here to C. So the first thing that I would do is divide everything by 2. Oops, and get those numbers to be a little bit smaller. And then I kind of pre-plan in my head, if I move this 5 over, it will become negative 5. And my middle term is negative 4. Is there a way that I can make these numbers so that I can solve by factoring? And I can, in fact, I can do negative 5 and positive 1. So once again, I can factor it. And I'm going to get positive 5 and negative 1 as my x-intercepts. I'm going to jump up here to letter B. So again, we can try thinking of this x method, but unfortunately there's no numbers that are going to multiply to 2 that add to negative 2. So we're going to have to use the quadratic formula. So we set up negative b plus or minus the square root. B squared would be 4, so I just write 4. I'm not going to write negative 2 squared. Cut down on my writing a little bit. Minus 4. A is 1, so typically I don't write, if my a value is 1, I don't write 1 because 1's not going to change 4. But I will for today just because this is new. So we have minus 4 a c. And that's all over 2a, which in this case would be 2. All right, and then we're going to clean it up a little bit, so we get positive 2. And personally, I would do 4 times 1 times 2 first and get 8, and then I would do 4 minus 8 and get negative 4. Remembering PEMDAS, we have to multiply before we subtract. And then this can become 2 plus or minus 2i, and it's all over 2. And then a nice little factoring trick you can do is normally you would split this into 2 over 2 plus or minus 2 over 2i. Both those fractions reduce the exact same way, so I'm going to be a little lazy and just think in my head, divide by 2, divide by 2, divide by 2. So if you can do it to everything, then there's no need to separate them and do them individually. So I'm left with 1 plus or minus 1i. And you don't have to write all over 1, of course. You can just leave it like that. We'll jump here to letter D. So depends what you want to do first. I have kids that tend to mess up when they see negatives, so I'm actually just, for good habit's sake, I'm going to move the 20y squared to the left. So it looks a little bit more normal to me now. And I know that 4 definitely goes into these, so I'm going to divide everything by 4. Now, a is not 1, so I don't know that if you try to use that x method of factoring, I don't know that that's going to save you work. Maybe it will, but I'm just not sure that that's going to be faster than the quadratic formula. So usually if my a isn't 1, I go to the quadratic formula. So again, we're going to do opposite b plus or minus the square root. B squared would be 4. So b squared minus 4ac. And that's all over 2 times a, which is 10. And then we'll clean it up a little bit. So again, I'm going to do 4 times 5 times 3. So this would be 20. 20 times 3 is 60. 4 minus 60 is negative 56. Now, I believe 56 is 4 times 14. Let's check. So you get 40 and 16, and that is 56. So you can break 56 down. So we'll have plus or minus. It would be 4 and 14, so that would be 2i root 15, or 2i root 14. And that's all over 10. And then again, I'm thinking divide by 2, divide by 2, divide by 2. So that kind of saved me a little bit of writing. And my final answer is negative 1 plus or minus I root 14 all over 5. And you can just leave it like that because there's no more fractions that you can reduce. So what I'll do is pause this video and I'll come up with the work and answers for E and F, and I'll let it up to you to figure out which method you're going to use to do those problems. Alright, so in the first one, we definitely want to move the 2 over, and I always like to write it in standard form. And I'm not a fan of having a negative in front of m squared, so I personally chose to divide everything by negative 1. Now you don't have to do that. You'll see that you may have some negatives where I have some positives in here, but it works out to the same answer. So it really doesn't matter if you choose to do that or not. You should get the same answer, but you should get negative 3 plus or minus root 17 over 2. And then for letter F, we cannot begin the quadratic formula unless this is equal to 0. So we have to make sure that that 20 is over. And then we're going to substitute our numbers in the quadratic formula again, and we end up getting kind of a nasty answer. Looks like you get 321 inside the root. And 321 breaks down into 3 and 107, and both of those are prime. So you cannot simplify that radical. But what you can do is you can separate your fractions so that you can reduce the 9 over 6. So this should be your final answer. Alright, so going back to the discriminant, because you'll have some discriminant questions, and even though that word may look scary to you, you want to smile when they ask you for discriminant, because all they want you to do is this right here. They just want you to do b squared minus 4ac. So you're doing a very small portion of the quadratic formula. So we have 3 rules regarding discriminant that you are responsible for remembering. And the first one is if your discriminant is positive. So if you get a positive number inside your root, that means you're going to have 2 real solutions. They could be really nice, pretty numbers like 3 and negative 2, or they could be ugly, like something with like a root 5 in it. That is still a number, it's just a really nasty decimal. But it does exist. So that just means you have 2 real answers. If your discriminant is 0, so if you get root 0, you're only going to get 1 real answer. And if you think about the quadratic formula, that should make sense because the whole reason that we usually get 2 answers is because of the plus minus. That breaks it into 2 separate problems. But if you have root 0, that's just 0. So there's no difference if you add 0 or subtract 0, you're going to get the same answer. So you're just going to get 1 answer for that problem. And then for the last problem, if you have a negative discriminant, that means you have 2 imaginary answers. So you won't see your parabola cross the x-axis. Alright, that's what your graph would look like. It really wouldn't cross the x-axis. We'd have to use a whole different realm of graphing numbers, and we don't get into that at the high school level. So you think about it, should make sense. Like if you have root negative 5, that automatically becomes I root 5. So if you have a negative, you're going to have an I in the answer. So positive, 2 real, 0, 1 real, negative, 2 imaginary. So in the next video, we'll go ahead and walk through a few different problems, and then we'll kind of wrap it up with a word problem. And that'll be that.